The use of aliphatic nitro compounds in organic synthesis is a significant aspect which we will focus in our today's lecture with respect to retrosynthetic analysis. But before finding out the significance of aliphatic nitro compound, we should understand a typical condensation reaction which we have studied in earlier sessions. Just take an example of aldol condensation, which we have shown on the screen, in which the starting material such as aldehyde or ketone undergoes annualization. A base abstract beta proton, and it gives rise to formation of an annulate. This is an annulate which act as a nucleophile, and that adds to another neutral molecule of aldehyde or ketone for giving a beta hydroxy ketone. So the neutral molecule acts as an electrophile. As a result, we get a beta hydroxy ketone, which ultimately dehydrated to alpha beta unsaturated carbonyl compound. So here we can say that both the starting material, whether it is aldehyde or ketone, can act as a nucleophile, as in annulate, and electrophile as a neutral molecule. But if we want some certain species which do not plays out as an electrophile, but only we want to make them as an annulate or take them out for a nucleophilic role. So nitro or aliphatic nitro compounds offer an interesting example in this regard. For example, we have nitro compounds, mostly are readily available nitro compounds are nitromethane, and 2-nitropropane. These are readily available nitro compounds. In order to understand, let's consider the structure. These compounds are interesting because the nitro group stabilize the resultant carbanion very significantly once it is formed after abstraction of beta proton. So this stabilization is so much enhanced that even a weak base can abstract the proton for generating a carbanion. Which rearrange like this. So these species act as a nucleophile, and it can't add to another neutral molecule of nitromethane because the molecule doesn't act as a electrophile. It only led to formation of a nitroannulate, and this annulate could only function as a nucleophile. Nitro compounds are very important in organic synthesis because the nitro group offer an interesting functionality. These nitro group offer an interesting example of latent functionality. From latent functionality, we mean that this functional group can be transformed into other functional group, such as, for example, if we have a nitromethane, we can reduce it to nitroamines, or we can transform it into carbonyl group with the applications of titanium trichloride. Moreover, the nitroanolate can be alkylated as well. For example, we use this anolate in alkylation process as well. For example, just take an example of nitromethane. When it is treated with the base, it gives an anolate of nitro that can easily be alkylated. And this is again alkylated. For example, we have 2 alpha proton that can be realkylated twice. Or we can write it like, and this compound can be reduced or by transforming nitro functional group into an H2. So with the application of alkylation, we can introduce tertiary alkyl group into amines. For example, if we require a tertiary alkyl group linked to an amino functionality in different organic compounds, so we can utilize this application with the help of nitro or aliphatic nitro compounds. So besides these applications, we will focus on some other important applications by considering some examples. Let's consider chlorophytramine, which is an interesting appetite suppressant. This is chlorophytramine. Now we are subjecting it into retrosynthetic analysis. By doing functional group interconversion. To make the example simplify, no break or disconnect right over here. And we get that molecule of. So this is a simple retrosynthetic analysis of chlorophytramine. which can be obtained by first reacting the 2-nitropropane with a base, and then the enolate is treated to react with the benzyl or chlorobenzyl derivatives for generating a nitro compound, which is reduced into an amino compound in the end, because here the reduction nitro group has reduced in the presence of hydrogenation catalyst into an amino group. Now consider another example, because the application is significant in condensation reaction as well, especially when we talk of aliphatic nitro compounds, so we can utilize them in condensation reaction as well. It contains much like carbonyl compounds such as aldehyde and ketone in what we have seen in aldol condensation. Here we have nitromethane, which upon treatment with the base generate an enolate type compound that can be added to an aldehyde or ketone, much like in aldol condensation fashion. Or its protonation give and subsequent dehydration and alpha beta unsaturated nitro compound, much like alpha beta unsaturated aldehyde or ketone. So this is how the nitro compound participate in condensation reaction as well. Just we check out an example of diamine, which is used in synthesis of nylon. This is diamine. It is now subjected to retrosynthetic analysis. Because this step has formed through condensation of a nitromethane or aliphatic nitro compound with an aldehyde or ketone. We have here introduced, now we undergoes or shift an NH2 group into CN group. nitrile CN and CHO, because this reflects a simple Michael addition that can be proceeded in a simple way. So if we focus its retrosynthetic analysis, which is quite simple, first we will react the isopropyl formyl or aldehyde with a nitro compound, especially nitrile compound, that is unsaturated nitrile, or ethene nitrile in the presence of a base for generating a compound such as this one. This compound is obtained by treatment of aldehyde with ethene nitrile in the presence of base for this compound, and it is subjected to react with nitroethane in the presence of triethyl amine, so that we could obtain this compound first, and ultimately this compound is reduced, because we cannot reduce this compound at this stage because we have a formyl group as well. So first we transform the formyl group. Here just check out this example. Now in this example, first the formyl group is transformed into an alpha beta unsaturated nitro compound, and that nitro compound is ultimately reduced to the end stage. So here and this compound is ultimately reduced in the last stage, in which the nitro compound is formed. So this is how we can utilize the application of a nitro compound in condensation reaction as well. Now let us consider some other application of aliphatic nitric compound, especially they are used in Diel order reaction as well. We have a compound which is a stimulant and acts as a stimulant, phencamphamine. And this compound can be drawn like we have pH group, and to simplify, let me sketch it again. Now I am subjecting it into retrosynthetic analysis. I am performing a functional group interconversion. Again into a functional group interconversion. Now deal order. And this compound can be made from plus nitromethane in a condensation reaction. So this is a simple application how we can transform the or utilize nitro compound in deal order. As far as it synthesis is involved, usually first benzaldehyde, no synthetic analysis. So this compound, which is benzaldehyde, is treated with nitromethane in the presence of base for giving a trans alpha beta unsaturated nitro compound, and this nitro compound is treated with diene in a deal order fashion, and we will get let me sketch for clarity. This compound is trans, in which the nitro group is in endo direction for stability purpose. This compound is subjected to reduction, in which the nitro group is transformed into an amino group. This is pH and H2, and in the end we react it with acetaldehyde and then subject it to hydrogenation for transforming this group into the product what we have in target material. So this is target material. Besides a deal order reaction, we can also utilize nitro compound in Michael addition as well. We can also transform a nitro functionality into and carbonyl functionality because we can use titanium trichloride for transforming NO2 group into a carbonyl functionality. So this is all about the application of nitro compounds, especially aliphatic nitro compound in organic synthesis. I hope many things would have been cleared right now by presenting different example of condensation reaction, alkylation reaction, because this all represent the application of nitro compound in organic synthesis. Thank you for watching this session.